Hi everyone, welcome to this Artificial Intelligence 2022 full course video by Simplilearn. Artificial intelligence applications are being widely used in various fields to solve business problems. In this video, you will learn the important skills that will help you understand AI and its implementation better. Our highly proficient trainers will take you through this course. So let's look at the agenda for today's topic. We will start by learning the basics of AI from a short animated video. Then, you will learn the top 10 AI technologies and companies for 2022. Next, you will understand machine learning in detail and explore some of the top machine learning algorithms that are used to build intelligent machines. So here you will look at linear regression, logistic regression, decision tree, k-means clustering, KNN, PCA, and other techniques such as regularization, reinforcement learning, and Q-learning. Moving forward, you will understand the working of artificial neural networks and deep learning algorithms such as convolutional neural network, recurrent neural network, Keras image classification, and sequential model. So let's get started.
Picture this, a machine that could organize your cupboard just as you like it, or serve every member of the house a customized cup of coffee. Makes your day easier, doesn't it? These are the products of artificial intelligence. But why use the term artificial intelligence? Well, these machines are artificially incorporated with human-like intelligence to perform tasks as we do. This intelligence is built using complex algorithms and mathematical functions. But AI may not be as obvious as in the previous examples. In fact, AI is used in smartphones, cars, social media feeds, video games, banking, surveillance, and many other aspects of our daily life. The real question is, what does an AI do at its core? Here is a robot we built in our lab, which is now dropped onto a field. In spite of a variation in lighting, landscape, and dimensions of the field, the AI robot must perform as expected. This ability to react appropriately to a new situation is called generalized learning. The robot is now at a crossroad, one that is paved and the other rocky. The robot must determine which path to take based on the circumstances. This portrays the robot's reasoning ability. After a short stroll, the robot now encounters a stream that it cannot swim across. Using the plank provided as an input, the robot is able to cross this stream. So, our robot uses the given input and finds the solution for a problem. This is problem solving. These three capabilities make the robot artificially intelligent. In short, AI provides machines with the capability to adapt, reason, and provide solutions. Well, now that we know what AI is, let's have a look at the two broad categories an AI is classified into. Weak AI, also called narrow AI, focuses solely on one task. For example, AlphaGo is a maestro of the game Go, but you can't expect it to be even remotely good at chess. This makes AlphaGo a weak AI. You might say Alexa is definitely not a weak AI, since it can perform multiple tasks. Well, that's not really true. When you ask Alexa to play Despacito, it picks up the keywords play and Despacito, and runs a program it is trained to. Alexa cannot respond to a question it isn't trained to answer. For instance, try asking Alexa the status of traffic from work to home. Alexa cannot provide you this information, as she is not trained to. And that brings us to our second category of AI, strong AI. Now, this is much like the robots that only exist in fiction as of now. Ultron from Avengers is an ideal example of a strong AI. That's because it's self-aware and eventually even develops emotions. This makes the AI's response unpredictable. You must be wondering, well, how is artificial intelligence different from machine learning and deep learning? We saw what AI is. Machine learning is a technique to achieve AI, and deep learning, in turn, is a subset of machine learning. Machine learning provides a machine with the capability to learn from data and experience through algorithms. Deep learning does this learning through ways inspired by the human brain. This means through deep learning, data and patterns can be better perceived. Ray Kurzweil, a well-known futurist, predicts that by the year 2045, we would have robots as smart as humans. This is called the point of singularity. Well, that's not all. In fact, Elon Musk predicts that the human mind and body will be enhanced by AI implants, which would make us partly cyborgs. So, here's a question for you. Which of the below AI projects don't exist yet? A. An AI robot with citizenship. B. A robot with a muscular skeletal system. C. AI that can read its owner's emotions. D. AI that develops emotions over time. Give it a thought and leave your answers in the comment section below. Since the human brain is still a mystery, it's no surprise that AI too has a lot of unventured domains. For now, AI is built to work with humans and make our tasks easier. However, with the maturation of technology, we can only wait and watch what the future of AI holds for us. Well, that is artificial intelligence for you in short. Do not forget to leave your answer to the quiz in the comment section below. Also, like, share, and subscribe to our channel if you enjoyed this video. Stay tuned and keep learning.
Now, let's look at the different types of artificial intelligence. So AI can be classified based on capabilities and functionalities. Under capabilities, there are three types of artificial intelligence. They are narrow AI, general AI, and super AI. Under functionalities, we have four types of artificial intelligence: reactive machine, limited memory, theory of mind, and self-awareness. Let's look at them one by one. First, we will look at the different types of artificial intelligence based on capabilities. So what is narrow AI? Narrow AI, also known as weak AI, focuses on one narrow task and cannot perform beyond its limitations. It aims at a single subset of cognitive abilities and advances in that spectrum. Applications of narrow AI are becoming increasingly common in our day-to-day lives as machine learning and deep learning methods continue to evolve. Apple's Siri is a simple example of a narrow AI that operates with a limited predefined range of functions. Siri often has challenges with tasks outside its range of abilities. IBM Watson supercomputer is another example of narrow AI, which applies cognitive computing, machine learning, and natural language processing to process information and answer your questions. IBM Watson once outperformed human contestant Ken Jenkins to become the champion on the popular game show Jeopardy! Other examples of narrow AI include Google Translate, image recognition software, recommendation systems, spam filtering, and Google's page ranking algorithm. Next, we have general artificial intelligence or general AI. General AI, also known as strong AI, has the ability to understand and learn any intellectual task that a human can. General artificial intelligence has received a $1 billion investment from Microsoft through OpenAI. It allows the machine to apply knowledge and skills in different contexts. AI researchers and scientists have not achieved strong AI so far. To succeed, they would need to find a way to make machines conscious, programming a full set of cognitive abilities. Fujitsu built the K computer, which is one of the fastest computers in the world. It is one of the most notable attempts at achieving strong AI. It took 40 minutes to simulate a single second of neural activity, so it is difficult to determine whether or not strong AI will be achieved in the near future. Tianhe 2 is a supercomputer created by China's National University of Defense Technology. It currently holds the record for CPS at 33.86 petaflops. Although it sounds exciting, the human brain is estimated to be capable of 1 exaflop. Now CPS means characters per second that a system can process. Third in the list of AI that is based on capabilities, we have Super AI. Super AI exceeds human intelligence and can perform any task better than a human. The concept of artificial superintelligence sees AI evolve to be so akin to human emotions and experiences that it doesn't just understand them, it evokes emotions, needs, beliefs, and desires of its own. Its existence is still hypothetical. Some of the key characteristics of Super AI include the ability to think, solve puzzles, make judgments, and decisions on its own. Now, If you have enjoyed watching this video so far, please make sure to subscribe to our YouTube channel and hit the bell icon to stay updated with all the latest technologies. Also, if you have any questions related to this video, please put it in the chat section. Our team of experts will help you address your questions. Moving ahead, now we will see the different types of artificial intelligence based on functionalities. In this category, first we have reactive machine. A reactive machine is the basic form of AI that does not store memories or use past experiences to determine future actions. It works only with present data. They simply perceive the world and react to it. Reactive machines are given certain tasks and don't have capabilities beyond those duties. IBM's Deep Blue, which defeated chess grandmaster Garry Kasparov, is a reactive machine that sees the pieces on a chessboard and reacts to them. It cannot refer to any of its prior experiences and cannot improve with practice. Deep Blue can identify the pieces on a chessboard and know how each moves. It can make predictions about what moves might be next for it and its opponent. It can choose the most optimal moves from among the possibilities. Deep Blue ignores everything before the present moment. All it does is look at the pieces on the chessboard as it stands right now and choose from possible next moves. Up next, we have limited memory. Limited memory AI learns from past data to make decisions. The memory of such systems is short-lived. While they can use this data for a specific period of time, they cannot add it to a library of their experiences. This kind of technology is used for self-driving vehicles. They observe how other vehicles are moving around them in the present and as time passes. That ongoing collected data gets added to the static data within the AI machine, such as lane markers and traffic lights. They are included when the vehicle decides to change lanes to avoid cutting off another driver or being hit by a nearby vehicle. Mitsubishi Electric is a company that has been figuring out how to improve such technology for applications like self-driving cars. Then we have theory of mind. Theory of mind represents a very advanced class of technology and exists as a concept. This kind of AI requires a thorough understanding that the people and the things within an environment can alter feelings and behaviors. It should be able to understand people's emotions, sentiment, and thoughts. Even though a lot of improvements are there in this field, this kind of AI is not complete yet. One real-world example of theory of mind AI is Kismet, a robot head made in the late 90s by a Massachusetts Institute of Technology researcher. Kismet can mimic human emotions and recognize them. Both abilities are key advancements in theory of mind AI, but Kismet can't follow gazes or convey attention to humans. Sophia from Hanson Robotics is another example where the theory of mind AI was implemented. Cameras within Sophia's eyes combined with computer algorithms allow her to see. She can follow faces, sustain eye contact, and recognize individuals. She is able to process speech and have conversations using natural language subsystem. Finally, we have self-awareness. Self-awareness AI only exists hypothetically. Such systems understand their internal traits, states, and conditions and perceive human emotions. These machines will be smarter than the human mind. This type of AI will not only be able to understand and evoke emotions in those it interacts with, but also have emotions, needs, and beliefs of its own. While we are probably far away from creating machines that are self-aware, we should focus our efforts towards understanding memory, learning, and the ability to base decisions on past experiences.
I am Kirtana, and today we shall be talking about the top 10 artificial intelligence technologies. Before getting into the video, here's a gentle reminder to subscribe to our channel and hit the bell icon so that you wouldn't miss any update from us. So, without further ado, let's quickly jump into the topic. In the list we have natural language generation, smart devices, virtual agents, speech recognition, augmented reality, machine learning, robotic process automation, decision management, deep learning, and finally image recognition. Please note that the list is in no particular order. Natural language generation. Communicating or conveying the information efficiently and transparently is very much crucial in communication. To say the right words in the right sequence, to convey the message clearly, humans often find it tricky, and when it comes to machines, it's trickier. Natural language generation is a subdiscipline of artificial intelligence and is a trendy technology that converts the structured data into a native language. The machines are programmed in such a way that the algorithms convert the data into a desirable format for the users. This technology is widely used in customer service, report generation, and summarizing business intelligence insights. Some of the sample vendors are Ativio, Automated Insights, SAS, Cambridge Semantics, Digital Reasoning, Narrative Science, etc. On the list next we have smart devices. With every passing day, smart devices are becoming more popular and more trendy. Technologies that people were using once upon a time are now remodeled and modified as smart devices. They can be used in almost every industry to improve efficiency and optimize the operations. Smart devices are everyday objects made intelligent with advanced computations, which include artificial intelligence and machine learning. They are electronic gadgets that are able to connect, share, and interact with its users and other smart devices. Some of the smart devices are smart watches, smart glasses, smartphones, smart speakers, etc. Virtual agents. They are computer-generated intelligence that provides online customer assistance. They can effectively communicate with humans. In most of the web and mobile applications, we see chatbots as customer service agents who interact with us answering our queries. In simple, virtual agents are a manifestation of a technology which aims to create an effective but digital impersonation of humans. Virtual agents can make reservations, book an appointment, place an order, and can even avail product information. Some of the best examples of virtual agents are Google Assistant and Amazon Alexa. And the companies that provide virtual agents are Microsoft, Google, Amazon, and Assist AI. Next, we have speech recognition. Speech recognition is yet another subdiscipline of artificial intelligence, which is used to convert human speech into a comprehensive and useful format for computer applications to process. It can be said as a bridge between computer interactions and humans. It's presently used in interactive voice response systems and mobile applications. Some of the companies offering speech recognition services are Nuance Communications, OpenText, NICE, and Verint Systems. Augmented reality. Yet another trendy technology in the field of artificial intelligence, augmented reality is an enhanced version of the real physical world that is achieved using sound, digital visual elements, and other sensory stimuli delivered via technology. Augmented reality uses the existing environment and adds information to it to make a new artificial environment. It alters the perception of the real-world environment. Augmented reality is making its way into several retail stores that make makeup selection and furnishing much more fun and interactive.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Machine learning. Machine learning is an application and an important branch of artificial intelligence which refers to machines being able to learn by themselves without being explicitly programmed. It enables systems to learn and improve from experience automatically. Machine learning platforms are becoming more and more popular with the help of algorithms, APIs, big data, and applications and training tools. Enterprises are heavily investing in machine learning to reap its benefits for the various domains. Machine learning is widely used for categorization and prediction. Some of the sample vendors are Amazon, Fractal Analytics, Google, Microsoft, etc. Robotic process automation. Configuring a robot to interpret, communicate, and analyze data is robotic process automation. It uses scripts and other methods to automate the human actions, which in turn supports efficient business processes. Robotic process automation is widely used in those areas where the physical presence of a human is dangerous. Fields like warfare, mining, etc. is where it's currently being used. We need to remember that artificial intelligence is not meant to replace humans, but instead it is to complement their abilities and reinforce human talent. Companies that are focusing on robotic process automation are Pegasystems, Automation Anywhere, Blue Prism, etc. Next on the list we have decision management. Decision management is yet another technology in artificial intelligence that helps companies make valid decisions by providing up-to-date and relevant information and performing analytic functions. Artificial intelligence, when combined with decision management, helps translate customer data into predictive models of key trends. It also helps in making quick decisions, avoidance of risks, and in the automation of the process. Decision management is widely used in the healthcare sector, financial sector, insurance sector, e-commerce, and many more. Some of the companies that provide this service are Informatica, Advanced Systems Concepts, Pegasystems, Mana, etc. Deep learning. Deep learning is a branch of artificial intelligence that mimics the workings of the human brain in processing data. This data is used for a variety of purposes like recognizing speech, detecting objects, translating languages, and making decisions. Deep learning uses hierarchical level of artificial neural networks for carrying out the process of machine learning, which is used across several industries for various applications. Some of the sample vendors are Deep Instinct, Fluid AI, MathWorks, Saffron Technology, etc. At last, we have image recognition. Image recognition is the process of detecting an object or feature in a digital image or video. It can be used to analyze clients and their opinions, verify users based on their faces, detect license plates, and diagnose diseases. The present-day image recognition is comparable to human visual perception. Many social media platforms like Facebook use this technology to enhance image search and aid visually impaired users. Clarify, Googums, and SenseTime provide this technology.
Decades ago, the term artificial intelligence was just another Frankenstein story, but today it could be a citizen in your next door. Right from its genesis, artificial intelligence was programmed to probe into human life and eliminate the fortifications of the impossibilities in many areas like healthcare, transportation, communication, and much more. There are hundreds and thousands of organizations, tech communities, and engineers worldwide working round the clock to make miracles a reality. And today, we are going to discuss the top 10 amongst those who are contributing a significant part. So here we are, the top 10 artificial intelligence companies to watch in 2022. At number 10, we have Viz AI. Viz AI is a revolutionary approach to dramatically improvise the way healthcare is delivered. Viz AI focuses on implementing artificial intelligence to diagnose and detect abnormalities in the human body via CT, CTA, MRI, X-ray, EKG, ultrasound, etc. This AI coordinates both the patient and healthcare professionals at the same time. The patient reports are shared via mobile to all the concerned medical teams. Results are astonishing. With Wiz AI, there is a significant improvement in productivity and reduction of time required for patient treatment and discharge. Wiz AI was founded in 2016 and established in November 2021. The company runs with 223 employees and the headquarters is in San Francisco. Wiz AI mainly focuses on improving and filling all the gaps between patients and healthcare professionals. Wiz AI offers handsome salaries to its employees. In India, the salaries range from 4 lakhs to 18 lakhs per annum, and in America, the wages range from $110,000 to $210,000 per annum. So at number 9, we have FarmWise. 10 years ago, an automated weed-killing robo was science fiction. Now, it's rise of practical weed-killing robos with millimeter precision thanks to FarmWise. The first product of the Californian-based company was an automated robo-weeder based on AI, computer vision, and also robotics. The robo would eliminate weeds from the vegetable fields. FarmWise intends to build innovative systems and efficient procedures that help farmers streamline farming with efficiency. FarmWise was established in the year 2020. The company functions with 50 employees on board and actively looking for expansion. The company follows the procedure of paying farming equipment employees and contract personnel hourly. FarmWise makes an annual turnover of $8.5 million. On average, an AI/ML engineer at FarmWise earns anywhere around $113,000 per annum. Up next, we have AMP Robotics. At number 8, we have AMP Robotics. While others are busy trying to revolutionize mankind with AI, AMP Robotics came up with an innovative idea that happens to be a kind gesture of gratitude towards nature. AMP AI designed an artificial intelligence robo that recycles e-waste, plastic waste, and waste from construction sites, and much more. The robo precisely identifies paper, plastics, and metals by learning and recognizing them via color, size, shape, and a few more factors. The Colorado-based company is currently operational with 137 employees in total and looking forward to expand the idea globally. AMP Robotics aims to reimagining recycling and to create a world without waste through artificial intelligence. AMP Robotics pays handsome salaries to their employees with an average salary of an employee AMP. Robotics varies between $96,000 to $131,000 per annum. Coming up next is a giant. At number 7, we have Automation Anywhere. Automation Anywhere is a global robotics automation and software company founded in the year 2003. The company's headquarters is located in San Jose, California. The global RPA leader offers cloud-native, web-based intelligent automation solutions to the world's leading cloud companies. Automation Anywhere's Automation 360 offers a variety of intelligent tools and self-learning systems to automate every redundant task. Automation Anywhere is focusing on transforming the companies to be RPA-oriented, and the current COVID situations have triggered the need for automation even more. A recent survey states the RPA adoption rates will increase by 57% in just one more year. The globally recognized multinational company works with more than 2,200 plus employees on board. The company pays decent salaries as well. At number 6, we have Microsoft AI. Microsoft integrated AI into cloud computing. Microsoft's AI platform provides robust solutions to cloud-related problems. Microsoft's AI division is headquartered in Redmond, Washington, with around 5,000 employees specifically in the AI division, and aims to train and certify 15,000 employees by 2022. Microsoft AI is a robust framework designed for developing AI solutions using machine learning, data science, robotics, IoT, and more. AI-enabled services accelerate productivity to a greater level. Microsoft Azure uses AI to get best-of-breed infrastructure with enterprise-grade security, availability, compliance, and manageability. Microsoft also pays handsome salaries to their employees. The average salary of an employee at the Microsoft AI division earns up to $160,000 per annum. At number 5, we have DataRobo. DataRobo has its headquarters in Boston. It is one of the AI cloud leaders, providing a unified platform to its cloud users to accelerate the delivery of AI to the cloud. DataRobo aims to understand and leverage the inherent capabilities of the platform. DataRobo has the caliber to help business analysts in building predictive analytics with no knowledge of machine learning. It uses automated ML to build and deploy accurate predictive models in a short span of time. The global cloud leader currently operates with more than 1,000 employees worldwide. DataRobo compensates its employees with handsome salaries. An average employee at DataRobo earns up to $160,000 per year and up to 3,400,000 rupees in India. At number 4, we have Amazon. The Alexa maker, Amazon, is one of the tech giants interested in adopting AI into its various divisions. Amazon calls its AI services Amazon Lex, Amazon Poly, Amazon Recognition, and Amazon Machine Learning. These services are accessible through a software API call or console. The Amazon AI suite of services can have text or voice conversations with an end user using a conversational chat ops interface. The Seattle-based tech giant is currently using AI for its smart home solutions. AI companies like Alexa and its business intelligence needs, Amazon is also conducting trials on drone delivery to save time and efforts to deliver goods and services to remote locations with ease. Amazon AI aims to provide biometric payments to its customers at cash-free stores. The approach is still in trials. Amazon calls it Just Walk Out technology. Amazon has enormous teams and pays decent salaries to its employees. For example, an employee at Amazon can earn up to 20 lakh rupees per annum in India and about $100,000 per annum in United States of America. At number 3, we have Databricks. Databricks is one of the best data-driven companies. Databricks lakehouses combine data warehouses, reliability, performance, and governance with the openness and flexibility of data lakes. Databricks is headquartered in San Francisco, California, and has 15 office locations across 11 countries. The company announces plans on delivering keynote on data and machine learning product innovations and the rise of the lakehouse architecture advancements. Databricks currently operates with 2,000 plus employees globally. The organization compensates its employees with handsome salaries. An average employee at Databricks makes about $154,000 and around 2.1 lakh rupees per annum in India. Next, we have Meta. At number 2, we have Meta. Meta, formerly known as Facebook, is innovating an advanced way of social interaction. Meta has integrated artificial intelligence and it's being called the Meta AI. Meta AI has its headquarters in Toronto, Canada. Meta AI has redesigned a new material and touch sensor with potential to boost the development of Metaverse. A team of researchers at the Metaverse have worked jointly with scientists at Carnegie Mellon University to build Reskin, a plastic 3 mm thick membrane with magnetic particles capable of measuring touch and sensation. A thrilling experiment Meta has under its sleeve, I would say. Meta currently operates remotely with about 350 employees on board. Critics also state that Meta pays a vast salary to its AI experts with an average salary of $1,750,000 paid to the employees at Meta AI. At number 1, we have Google AI. Google AI is the division of Google dedicated to artificial intelligence. CEO Sundar Pichai announced it at Google I/O 2017. Google AI has its headquarters in California. Google AI is demonstrating its quantum computing supremacy with its new and powerful Cinnamore processor. Google's AI is one of the most widespread technologies. It's almost everywhere, from your language translations to helping people with speech impairments to have a successful conversation, social media interactions, shopping lists, and assisting users with GPS, sending alerts to its users about natural calamities and saving them. Google AI has announced that its research team is designing next-generation AI chips for a smart future. In addition, a new AI model allows artificial intelligence to perform chip design that more efficiently solves unique aspects of any problem with an artificial neural network. Google AI currently works with our 4 divisions with massive teams. We have come to an end of this session on the top 10 AI companies to watch out for in 2022.
Hello and welcome to Machine Learning Tutorial Part 1. This is Part 1 of a machine learning series put on by Simplilearn. My name is Richard Kirshner. I'm with the Simplilearn team. That's www.simplilearn.com. Get certified, get ahead. What's in it for you today? Well, we'll start off with a brief explanation of why machine learning and what is machine learning. And then we'll get into a few of the types of machine learning. Machine learning algorithms, linear regression, decision trees, support vector machine, and finally we'll do a use case where we're going to classify whether a recipe is of a cupcake or a muffin using the SVM or the support vector machine. Sounds like a delicious way to explore machine learning. So why machine learning? Why do we even care about having these computers come up and be able to do all these new things for us? Well, because machines can now drive your car for you. It's still very in the infant stage, but it's just exploding, as we see with Google's Waymo, and then Uber had their program, which unfortunately crashed. They know that this is huge. This is going to be the huge industry to change our whole transportation infrastructure. Machine learning is now used to detect over 50 eye diseases. Do you know how amazing that is to have a computer that double checks for the doctor for things they might miss? That's just huge in the health industry. Pretty soon they actually do already have that in some areas where maybe not for eyes, but for other diseases where they're using the camera on your phone to help pre-diagnose before you go in and see the doctor. And because the machine can now unlock your phone with your face. I mean, that's just cool, having it being able to identify your face or your voice and be able to turn stuff on and off for you depending on where you're at and what you need. Talking about an ultimate automation, our world we live in. And as we dig in deeper, we have a nice example of Facebook. As you can see here, they have the Facebook post with Halloween. Comment yes if you want it. Order here. Nobody likes spam posts on Facebook that annoy them into interacting with likes, shares, comments, and other actions. I remember the original ones were all, if you don't click on here, you will have bad luck or some kind of fear factor. Well, this is a huge thing in a social media when people are getting spammed, and so this tactic, known as engagement bait, takes advantage of Facebook's newsfeed algorithm by choosing engagement in order to get the greater reach. To eliminate engagement bait, the company reviewed and categorized hundreds of thousands of posts to train a machine learning model that detects different types of engagement bait. So in this case we're using Facebook, but this is of course across all the different social media. They have different tools they're building, and the Facebook scroll GIF will be replaced. Kind of like a virus coming in there. It notices that there's a certain setup with Facebook and it's able to replace it. And they have like vote baiting, react baiting, share baiting. They have all these different, these are kind of general titles, but there certainly are a lot of ways of baiting you to go in there and click on something. So they fed all this data was fed into the machine, and then they have the new post. The new post comes up that takes over part of the Facebook setup, and that's what you're looking at. You're looking at this new post that's replaced, like a virus has replaced that. So what Facebook did to eliminate this is they start scanning for keywords and phrases like this and checks the click-through rate. So it starts looking for people who are clicking through it without even looking at it, or clicking through it and it's not something that normally would be clicked through. Once Facebook has scanned for these keywords and phrases, it is now able to identify the spam coming in. And this makes your life easier, so you're not getting spammed. It's not like walking through an airport, and in a lot of countries you have like hundreds of people trying to sell you timeshare. Come join us, sign up for this. Eliminates that annoyingness, so now you can just enjoy your Facebook and your cat pictures, or maybe it's your family pictures. Mine is family. Certainly people like their cat pictures too. Another good example is Google's DeepMind project AlphaGo. A computer program that plays a board game Go has defeated the world's #1 Go player, and I hope I say his name right, Kiji. The Ultimate Go Challenge game of 3 of 3 was on May 27th, 2017, so it was just last year that this happened. And what makes this so important is that, Go is a game, so it's not like you're driving a car or something in our real world, but they are using games to learn how to get the machine learning program to learn. They want it to learn how to learn. And that is a huge step. A lot of this is still in its infant stage as far as development, as we saw what happened with the, as I referred to earlier, the Uber cars. They lost their whole division because they jumped ahead too fast. So still in an infant stage, but boy, is this like the beginning of just an amazing world that is automated in ways we can't even imagine what tomorrow's going to look like. We've looked at a lot of examples of machine learning, so let's see if we can give a little bit more of a concrete definition. What is machine learning? Machine learning is the science of making computers learn and act like humans by feeding data and information without being explicitly programmed. And we see here we have a nice little diagram where we have our ordinary system. Your computer, nowadays you can even run a lot of this stuff on a cell phone because cell phones have advanced so much. And then with artificial intelligence and machine learning, it now takes the data and it learns from what happened before. And then it predicts what's going to come next. And then really the biggest part right now in machine learning that's going on is it improves on that. How do we find a new solution? So we go from descriptive, where it's learning about stuff and understanding how it fits together, to predicting what it's going to do, to post-scripting, coming up with a new solution. And when we're working on machine learning, there's a number of different diagrams that people have posted for what steps to go through. A lot of it might be very domain specific. So if you're working on photo identification versus language versus medical or physics, some of these are switched around a little bit or new things are put in. They're very specific to the domain. This is kind of a very general diagram. First, you want to define your objective. Very important to know what it is you're wanting to predict. Then you're going to be collecting the data. So once you've defined an objective, you need to collect the data that matches. You spend a lot of time in data science collecting data, and the next step, preparing the data. You got to make sure that your data is clean going in. There's the old saying, bad data in, bad answer out, or bad data out. And then once you've gone through and we've cleaned all this stuff coming in, then you're going to select the algorithm. Which algorithm are you going to use? You're going to train that algorithm. In this case, I think we're going to be working with SVM, the support vector machine. Then you have to test the model. Does this model work? Is this a valid model for what we're doing? And then once you've tested it, you want to run your prediction. You want to run your prediction or your choice or whatever output it's going to come up with. And then once everything is set and you've done lots of testing, then you want to go ahead and deploy the model. And remember I said domain specific. This is very general as far as the scope of doing something. A lot of models you get halfway through and you realize that your data is missing something and you have to go collect new data because you've run a test in here someplace along the line. You're saying, hey, I'm not really getting the answers I need. So there's a lot of things that are domain specific that become part of this model. This is a very general model, but it's a very good model to start with. And we do have some basic divisions of what machine learning does that's important to know. For instance, do you want to predict a category? Well, if you're categorizing things, that's classification. For instance, whether the stock price will increase or decrease. So in other words, I'm looking for a yes-no answer. Is it going up or is it going down? And in that case, we'd actually say, is it going up? True. If it's not going up, it's false, meaning it's going down. This way, it's a yes-no, 0, 1. Do you want to predict a quantity? That's regression. So remember, we just did classification. Now we're looking at regression. These are the two major divisions in what data is doing. For instance, predicting the age of a person based on the height, weight, health, and other factors. So based on these different factors, you might guess how old a person is. And then there are a lot of domain-specific things, like do you want to detect an anomaly? That's anomaly detection. And this is actually very popular right now. For instance, you want to detect money withdrawal anomalies. You want to know when someone's making a withdrawal that might not be their own account. We've actually brought this up because this is really big right now. If you're predicting the stock, whether to buy stock or not, You want to be able to know if what's going on in the stock market is an anomaly, use a different prediction model because something else is going on, you got to pull out new information in there, or is this just the norm? I'm going to get my normal return on my money invested. So being able to detect anomalies is very big in data science these days. Another question that comes up, which is on what we call untrained data, is do you want to discover structure in unexplored data? And that's called clustering. For instance, finding groups of customers with similar behavior given a large database of customer data containing their demographics and past buying records. And in this case, we might notice that anybody who's wearing a certain set of shoes goes shopping at certain stores, or whatever it is, they're going to make certain purchases. By having that information, it helps us to market or group people together so that we can now explore that group and find out what it is we want to market to them if you're in the marketing world. And that might also work in just about any arena. You might want to group people together, whether they're based on their different areas and investments and financial background, whether you're going to give them a loan or not. Before you even start looking at whether they're a valid customer for the bank, you might want to look at all these different areas and group them together based on unknown data. So you don't know what the data is going to tell you, but you want to cluster people together that come together. Let's take a quick detour for quiz time. Oh, my favorite. So we're going to have a couple questions here under quiz time, and we'll be posting the answers in the part 2 of this tutorial. So let's go ahead and take a look at these quiz times questions, and hopefully you'll get them all right, and it'll get you thinking about how to process data and what's going on. Can you tell what's happening in the following cases? Of course, you're sitting there with your cup of coffee and you have your checkbox and your pen trying to figure out what's your next step in your data science analysis. So the first one is grouping documents into different categories based on the topic and content of each document. Very big these days. You have legal documents, you have maybe it's a sports group documents, maybe you're analyzing newspaper postings, but certainly having that automated is a huge thing in today's world. B, identifying handwritten digits in images correctly. So we want to know whether they're writing an A or capital A, B, C. What are they writing out in their handwriting? C, behavior of a website indicating that the site is not working as designed. D, predicting salary of an individual based on his or her years of experience. Boy, HR hiring setup there. So stay tuned for part 2. We'll go ahead and answer these questions when we get to the part 2 of this tutorial. Or you can just simply write at the bottom and send a note to Simplilearn, and they'll follow up with you on it. Back to our regular content. And these last few bring us into the next topic, which is another way of dividing our types of machine learning, and that is with supervised, unsupervised, and reinforcement learning. Supervised learning is a method used to enable machines to classify, predict objects, problems, or situations based on labeled data fed to the machine. And in here you see we have a jumble of data with circles, triangles, and squares, and we label them. We have what's a circle, what's a triangle, what's a square, and we have our model training, and it trains it so we know the answer. Very important, when you're doing supervised learning, you already know the answer to a lot of your information coming in. So you have a huge group of data coming in, and then you have new data coming in. So we've trained our model. The model now knows the difference between a circle, a square, a triangle. And now that we've trained it, we can send in this case, a square and a circle goes in, and it predicts that the top one's a square and the next one's a circle. And you can see that this is being able to predict whether someone's going to default on a loan, because I was talking about banks earlier. Supervised learning on stock market, whether you're going to make money or not. That's always important. And if you are looking to make a fortune in the stock market, keep in mind it is very difficult to get all the data correct on the stock market. It is it fluctuates in ways really hard to predict. So it's quite a roller coaster ride. If you're running machine learning on the stock market, you start realizing you really have to dig for new data. So we have supervised learning. And if you have supervised, we should need unsupervised learning. In unsupervised learning, machine learning model finds the hidden pattern in an unlabeled data. So in this case, instead of telling it what the circle is, and what a triangle is, and what a square is, it goes in there, looks at them, and says, for whatever reason, it groups them together. Maybe it'll group it by the number of corners. And it notices that a number of them all have 3 corners, a number of them all have 4 corners, and a number of them all have no corners. And it's able to filter those through and group them together. We talked about that earlier with looking at a group of people who are out shopping. We want to group them together to find out what they have in common. And of course, once you understand what people have in common, maybe you have one of them who's a customer at your store, or you have 5 of them are customer at your store, and they have a lot in common with 5 others who are not customers at your store. How do you market to those 5 who aren't customers at your store yet? They fit the demographics of who's going to shop there, and you'd like them to shop at your store, not the one next door. Of course, this is a simplified version. You can see very easily the difference between a triangle and a circle, which might not be so easy in marketing. Reinforcement learning. Reinforcement learning is an important type of machine learning where an agent learns how to behave in an environment by performing actions and seeing the result. And we have here where in this case, a baby. It's actually great that they used an infant for this slide because the reinforcement learning is very much in its infant stages. But it's also probably the biggest machine learning demand out there right now, or in the future. It's going to be coming up over the next few years, is reinforcement learning and how to make that work for us. And you can see here where we have our action. In the action in this one, it goes into the fire. Hopefully the baby it was just a little candle, not a giant fire pit like it looks like here. When the baby comes out, and the new state is the baby is sad and crying because they got burned on the fire. And then maybe they take another action. The baby's called the agent because it's the one taking the actions. And in this case, they didn't go into the fire. They went a different direction, and now the baby's happy and laughing and playing. Reinforcement learning is very easy to understand because that's how, as humans, that's one of the ways we learn. We learn whether it is, you burn yourself on the stove, don't do that anymore. Don't touch the stove. In the big picture, being able to have a machine learning program or an AI be able to do this is huge because now we're starting to learn how to learn. That's a big jump in the world of computer and machine learning. And we're going to go back and just kind of go back over supervised versus unsupervised learning. Understanding this is huge because this is going to come up in any project you're working on. We have in supervised learning, we have labeled data. We have direct feedback. So someone's already gone in there and said, yes, that's a triangle. No, that's not a triangle. And then you predict an outcome. So you have a nice prediction. This new set of data is coming in and we know what it's going to be. And then with unsupervised training, it's not labeled. So we really don't know what it is. There's no feedback. So we're not telling it whether it's right or wrong. We're not telling it whether it's a triangle or a square. We're not telling it to go left or right. All we do is we're finding hidden structure in the data, grouping the data together to find out what connects to each other. And then you can use these together. So imagine you have an image and you're not sure what you're looking for. So you go in and you have the unstructured data, find all these things that are connected together. And then somebody looks at those and labels them. Now you can take that labeled data and program something to predict what's in the picture. So you can see how they go back and forth and you can start connecting all these different tools together to make a bigger picture. There are many interesting machine learning algorithms. Let's have a look at a few of them. Hopefully this gives you a little flavor of what's out there. And these are some of the most important ones that are currently being used. We'll take a look at linear regression, decision tree, and the support vector machine. Let's start with a closer look at linear regression. Linear regression is perhaps one of the most well-known and well-understood algorithms in statistics and machine learning. Linear regression is a linear model. For example, a model that assumes a linear relationship between the input variables x and the single output variable y. And you'll see this if you remember from your algebra classes, y equals mx plus c. Imagine we are predicting distance traveled y from speed x. Our linear regression model representation for this problem would be y equals m times x plus c, or distance equals m times speed plus c, where m is the coefficient and c is the y-intercept. And we're going to look at two different variations of this. First, we're going to start with time is constant. And you can see we have a bicyclist. He's got his safety gear on, thank goodness. Speed equals 10 meters per second. And so over a certain amount of time, his distance equals 36 kilometers. We have a second bicyclist who's going twice the speed, or 20 meters per second. And you can guess if he's going twice the speed and time is a constant, then he's going to go twice the distance. And that's easily to compute. 36 times 2, you get 72 kilometers. And so if you had the question of how fast would somebody who's going 3 times that speed, or 30 meters per second is, you can easily compute the distance in our head. We can do that without needing a computer. But we want to do this for more complicated data. So it's kind of nice to compare the two. But let's just take a look at that and what that looks like in a graph. So in a linear regression model, we have our distance to the speed. and we have our m equals the VE slope of the line. And we'll notice that the line has a plus slope. And as the speed increases, distance also increases, hence the variables have a positive relationship. And so your speed of the person, which equals y equals mx plus c, distance traveled in a fixed interval of time, and we could very easily compute, either following the line or just knowing it's 3 times 10 meters per second, that this is roughly 102 kilometers distance that this third bicyclist has traveled. One of the key definitions on here is positive relationship. So the slope of the line is positive. As distance increase, so does speed increase. Let's take a look at our second example where we put distance is a constant. So we have speed equals 10 meters per second. They have a certain distance to go, and it takes them 100 seconds to travel that distance. And we have our second bicyclist who's still doing 20 meters per second. Since he's going twice the speed, we can guess that he'll cover the distance in about half the time, 50 seconds. And of course you could probably guess on the third one, 100 divided by 30, since he's going 3 times the speed, you could easily guess that this is 33.333 seconds time. When we put that into a linear regression model or a graph, if the distance is assumed to be constant, let's see the relationship between speed and time. And as time goes up, the amount of speed to go that same distance goes down. So now your m equals a minus VE slope of the line. As the speed increases, time decreases, hence the variable has a negative relationship. Again, there's our definition, positive relationship and negative relationship dependent on the slope of the line. And with a simple formula like this, and even a significant amount of data, let's see with the mathematical implementation of linear regression. And we'll take this data. So suppose we have this data set where we have x, y, x equals 1, 2, 3, 4, 5, standard series, and the y value is 3, 2, 2, 4, 3. When we take that and we go ahead and plot these points on a graph, you can see there's kind of a nice scattering, and you could probably eyeball a line through the middle of it. But we're going to calculate that exact line for linear regression. And the first thing we do is we come up here and we have the mean of xi. And remember, mean is basically the average. So we added 5 plus 4 plus 3 plus 2 plus 1 and divide by 5. And that simply comes out as 3. And then we'll do the same for y. We'll go ahead and add up all those numbers and divide by 5. And we end up with the mean value of y of I equals 2.8. Where the xi references it's an average or means value, and the yi also equals a means value of y. And when we plot that, you'll see that we can put in the y equals 2.8 and the x equals 3 in there on our graph. We kind of gave it a little different color so you could sort it out with the dashed lines on it. And it's important to note that when we do the linear regression model should go through that dot. Now let's find our regression equation to find the best fit line. Remember, we go ahead and take our y equals mx plus c, so we're looking for m and c. So to find this equation for our data, we need to find our slope of m and our coefficient of c. And we have y equals mx plus c, where m equals the sum of x minus x average times y minus y average, or y means and x means, over the sum of x minus x means squared. That's how we get the slope of the value of the line. And we can easily do that by creating some columns here where we have x, y. Computers are really good about iterating through data, and so we can easily compute this and fill in a graph of data. And in our graph, you can easily see that if we have our x value of 1, and if you remember the xi, or the means value, is 3, 1 minus 3 equals a negative 2, and 2 minus 3 equals a negative 1, so on and so forth. And we can easily fill in the column of x minus xi, y minus yi, and then from those we can compute x minus xi squared and x minus xi times y minus yi. And you can guess it that the next step is to go ahead and sum the different columns for the answers we need. So we get a total of 10 for our x minus xi squared, and a total of 2 for x minus xi times y minus yi. And we plug those in, we get 2/10, which equals 0.2. So now we know the slope of our line equals 0.2. So we can calculate the value of c. That'd be the next step, is we need to know where it crosses the y-axis. And if you remember, I mentioned earlier that the linear regression line has to pass through the means value, the one that we showed earlier. We can just flip back up there to that graph, and you can see right here there's our means value, which is 3, x equals 3 and y equals 2.8. And since we know that value, we can simply plug that into our formula, y equals 0.2x plus c, So we plug that in and we get 2.8 equals 0.2 times 3 plus c, and you can just solve for c. So now we know that our coefficient equals 2.2. And once we have all that, we can go ahead and plot our regression line. Y equals 0.2 times x plus 2.2. And then from this equation, we can compute new values. So let's predict the values of y using x equals 1, 2, 3, 4, 5 and plot the points. Remember, the 1, 2, 3, 4, 5 was our original x values. So now we're going to see what y thinks they are, not what they actually are. And when we plug those in, we get y of designated with y of p. You can see that x equals 1 equals 2.4, x equals 2 equals 2.6, and so on and so on. So we have our y predicted values of what we think it's going to be when we plug those numbers in. And when we plot the predicted values along with the actual values, we can see the difference. And this is one of the things that's very important with linear regression in any of these models, is to understand the error. And so we can calculate the error on all of our different values. And you can see over here we plotted x and y predict. And we draw in a little line so you can sort of see what the error looks like there between the different points. So our goal is to reduce this error. We want to minimize that error value on our linear regression model. Minimizing the distance. There are lots of ways to minimize the distance between the line and the data points, like sum of squared errors, sum of absolute errors, root mean square error, etc. We keep moving this line through the data points to make sure the best fit line has the least square distance between the data points and the regression line. So to recap with a very simple linear regression model, we first figure out the formula of our line through the middle, and then we slowly adjust the line to minimize the error. Keep in mind this is a very simple formula. The math gets, even though the math is very much the same, it gets much more complex as we add in different dimensions. So this is only 2 dimensions, y equals mx plus c, but you can take that out to x, z, I, j, q, all the different features in there, and they can plot a linear regression model on all of those using the different formulas to minimize the error. Let's go ahead and take a look at decision trees, a very different way to solve problems in the linear regression model. Decision tree is a tree-shaped algorithm used to determine a course of action. Each branch of a tree represents a possible decision, occurrence, or reaction. We have data which tells us if it is a good day to play golf. And if we were to open this data up in a general spreadsheet, you can see we have the outlook, whether it's rainy, overcast, sunny, temperature, hot, mild, cool, humidity, windy, and did I like to play golf that day, yes or no? So we're taking a census. And certainly I wouldn't want a computer telling me when I should go play golf or not. But you could imagine if you got up in the night before, you're trying to plan your day, and it comes up and says tomorrow would be a good day for golf for you in the morning, and not a good day in the afternoon, or something like that. This becomes very beneficial, and we see this in a lot of applications coming out now where it gives you suggestions and lets you know what would fit the match for you for the next day or the next purchase or the next whatever, next meal out. In this case, is tomorrow a good day for playing golf based on the weather coming in? And so we come up and let's determine if you should play golf when the day is sunny and windy. So we found out the forecast tomorrow is going to be sunny and windy. And suppose we draw our tree like this. We're going to have our humidity, and then we have our normal, which is if you have a normal humidity, you're going to go play golf. And if the humidity is really high, then we look at the outlook. And if the outlook is sunny, overcast, or rainy, it's going to change what you choose to do. So if you know that it's a very high humidity and it's sunny, you're probably not going to play golf because you're going to be out there miserable, fighting off the mosquitoes that are out joining you to play golf with you. Maybe if it's rainy, working more in navigator research to pin north. Very clear. This is array for the your view report. Obviously, implants semi opposites all machine line amber from there. Your graphic. So go ahead and peep there. The next having variable cake broken particles cake. There. You can just take no dot day 2 is content the test part of different fit. I'm go ahead and tell it plus hand layer and because that dot so this is so or what often starting to make sense. Go ahead match table putting this actually that and all be cool in another content is specified and all complex this we have on the let's go ahead and huddle math b and go to the next base create one intercept num we're going to the support which value the map this is up down pi line. Go ahead and one seal. And this is what you take. Flour. And I want a couple of remember and show is one. That's when you run the all the different doing in looks good. And we want to go ahead and divide our books up. Well, organizing objects into groups based on similarity is clustering. And in this case, as we're looking at the book,